Hello, my name is KMartinez. I'm enrolled in EPSY 5380 for spring 2019, the Introduction to Educational Statistics course. This is my PowerPoint presentation on the statistical concept of correlation and what I call its ugly brother, the spurious correlation. First, it's important to know what a correlation is. A correlation shows how strongly pairs of variables are related. Some common examples you hear about are height and weight examples. So as you grow and get taller, you tend to get heavier. Also, age and shoe size is a pretty common correlation. As you get older, your shoe size changes. There are three different types of correlations: a positive correlation, a negative correlation, and no correlation. A positive correlation is when one variable increases, the other variable increases. A negative correlation is when one variable increases, but the other variable decreases. When there's no correlation, then there's no clear relationship between the variables. So here are some pretty simple examples of the different types of correlations. First, you have a positive correlation. In this positive correlation, you can see that as temperature increases, so does the number of ice cream cones that are sold. So when it's 30 degrees, they only sell one ice cream cone. When it's 50 degrees, they sold 3 ice cream cones. At 70 degrees, they sold 7 ice cream cones, and at 90 degrees, they sold 12 ice cream cones. That's a real clear positive correlation. Next, you have a negative correlation. In this example, as the temperature increases, the number of hot chocolates sold decreases. So at 30 degrees, there are 12 hot chocolates sold. At 50 degrees, there are 7 hot chocolates sold. At 70 degrees, there are 3 hot chocolates sold. And at 90 degrees, no one wants a hot chocolate. Next, you have no correlation. So in this example, I used Dr. Al McDash's favorite brisket sandwich, and it's sold at different amounts regardless of the temperature. Everybody wants a brisket sandwich year-round. So when you're computing correlations, researchers must be aware of its ugly brother, the spurious correlation. And this is when you have 2 or more variables that are correlated with no causality. So some examples here are from the Harvard Business Review. And you can see in the first example, these are pretty extreme examples. In the first example, as iPhone sales increase, it looks like there's an increase in deaths from falling down the stairs. In the second example, as consumption of high fructose corn syrup decreases, the spending on admission to sporting events in the United States increases. And in the third example, as auto sales decrease, so do trips to Universal's Island of Adventures in Orlando. So when you're looking at these relationships, you have to look really closely and be aware of how they're charted. Because if you charted the results in these examples separately, the y-axis for each chart will differ in the range and the proportional increase. So if you look at the first example with iPhones, the proportional increase for deaths caused by falling down the stairs is only 25 increments, whereas the number of iPhone sales is in an increment of 10 million iPhone sales. So you can look at that and see if you were to separate those, they would be charted completely differently. So to go back to our seasonal goodies as an example, as hot chocolate sales increase, so do cases of frostbite. In this relationship, you can see that there were 2 hot chocolates sold and a little over 2 cases of frostbite. And then when there were 4 hot chocolates sold, there were a little less than 4 cases of frostbite. And you can see as hot chocolate sales increase, so do cases of frostbite. So does that mean buying hot chocolate causes frostbite? I truly hope not. In this situation, you have to look for what's called the confounding variable. This is when you must consider any outside influence that changes the effect of a dependent and independent variable. The confounding variable can ruin an experiment and create useless results. So the confounding variable for the hot chocolate causes frostbite could be just really extremely cold temperatures, lack of appropriate clothing, or too much skin exposure during those frigid temperatures. There are many other things that could have caused frostbite, not buying hot chocolate. So watch out for those confounding variables so that you can analyze true correlations. And that correlation is important so that you can, based on the examples we've gone over, keep buying those hot chocolates in the winter, keep eating ice cream cones in the summer, and of course, enjoying brisket sandwiches year-round.